Hello, this is Pavel from DevOps Codes Academy. Welcome to another lesson about AWS Cloud and DevOps. Today we're gonna continue our journey with Terraform code. We will create application load balancer with a listener target group, and we will modify our EC2 instance from a public one to private, and we will redirect the traffic from public load balancer to the Nginx web server. Don't forget to subscribe our channel, leave a thumbs up, leave a comment if you need, and of course join our Facebook group DevOps Codes Academy. You can find the link in the description of this video. Let's do not waste the time and jump into the console. Okay, we are in Visual Studio Code. Let's start working on Terraform code. We're gonna create application load balancer resource. We're gonna deploy it inside our VPC, and we're gonna learn how to refer between resources. So our load balancer gonna be in public subnets. We will be able to reach out from the public internet, and then it will redirect the traffic from the public subnets to private subnets, and we're gonna use our EC2 instance that we created before with Nginx, but we will modify this code a little bit just to present how it works. And in later lessons we're gonna work on Docker, and we're gonna create some backend service in ECS to show you how to utilize Docker containers and auto scaling there. All right, let's find load balancer resource in Terraform, AWS LB. We can use both AWS ALB and also AWS LB. And we're gonna utilize application load balancer. Let's take the example resource, take to Visual Studio Code. We're gonna create a new file here. Let's call it lbtf, and we're gonna we can call it front. Can use the name here. We can stick to some convention. I will take it here. We can have it public ALB, application load balancer. Is this one an internal? No, we want to have it public, so we're gonna keep it false. Load balancer type application for layer 7. Security groups. This is something new that we have to create. Talking about security groups, we can find it in EC2 service. Security group is kind of firewall on the network interface level. We can define the traffic which we want to allow. So by default, everything is denied if we did not add any rule here. We have in our default security group for the default VPC, we have all traffic to be allowed from another security group. From the security group, I think it's the same one, yeah, from itself. I have added before SSH on port 22 from Open Internet, also port 80 for Nginx from Internet. So we have to create such a security group for our usage. So let's go to EC2. I think it was in EC2. We can find it here. Security group. No, it's in VPC. Okay. And a security group can have ingress and egress rules. So ingress it's for everything what's coming in, and egress it's for what's coming out. We can take an example from here. AWS security group. Let's create a new file, have it as GTF, and we can call it allow public ALB. So it will DevOps codes allow public ALB for the name, allow inbound traffic to public ALB application load balancer, and we start referring between resources. So we have to connect our security group with VPC. That's the way how it will be deployed. Security group is attached to VPC. So here you see an example of AWS vpc.main.id. We can do it in many different ways. One of it is just to copy an ID, but of course we don't want to hard code ID here. Oopsie, let's make it again. If we click here, details, VPC ID, copy. So we could have it here, but this is the default VPC, and we have our own VPC which we can create and we can delete it, right? So every time we're gonna recreate it, the ID will be different. So the best practice to write the code is to write as much as possible a generic code, an abstract code, that we will not hard code any values that might change with every deployment. So what we can do here, we can go back to our module of VPC, to the documentation of it. And you will see that we have inputs. Inputs are the fields that we have to provide to configure it, but we have also outputs. Outputs will give us values after resources are created. And we can find VPC ID, and this is a default one, we don't want it. And you can see there is an option to have the ID of the VPC once it's created. And maybe there's some example to show you here. In README file, you see the usage. Outputs, no, they don't provide it here. So what we can do, we can refer to module.vpc because we called it VPC dot one of the outputs defined here. So when we go to the VPC ID, we can have it module VPC. Terraform is already giving us a hint. And even, you see, we can find some of them here, so it's much easier. But I wanted to show you how to search for it in documentation. And we see that it's all blue, means that it's okay. And we will have ingress. So the traffic that we want to allow to the load balancer from the internet, we can have it TLS from internet. And we're gonna keep it because I will show you later on how to configure TLS and how to add a certificate in AWS. And we can have HTTP. We can also call it here HTTPS. And I think that if we change it here for port 80, IPv6 we are not using right now, so we can delete it. And seed blocks, we can have it public internet. That should be good. And for egress, it means that the outgoing traffic initiated from the load balancer, we could have it defined for the VPC seeder, the one that we defined it here. So we want to our load balancer to have possibility to communicate on all ports, and we could lower down to the port. We can try to make it on port 80, and we will see if we're gonna work or not, or we have to open it a little bit more wide. Okay, tags for now we're gonna delete. In future we're gonna have a default tags for all the provider. One more thing, you can see here that we have duplicated the seeder block for the VPC. To do not repeat values, we can have a variable. We can create a new file variables. We can have a variable, and let's call it VPC seeder. The type will be string. Description. It's always a good idea to put description. Seeder block used for VPC, and then we can have a default value. For now, let's use a default values here. We can override those defaults, but for now to keep it simple. And now we have a variable. Let's go to VPC. Instead of this string, we can refer to a variable. And we're gonna do the same here. VPC seeder, and you can see it's blue, means that it's okay. All protocols looks good. HTTP from internet, and we could also have a description here. HTTP to backend. Okay. So we have a security group, and we call it allow public ALB. So we're gonna create that, and we have to refer to this resource in our load balancer. So what I do usually, I just copy this value and I put it, and we have to refer to ID, and I will show you in a second. Make it dot and ID. So where does it come from? It comes, of course, from the documentation, security groups. When we go to the load balancer and we scroll down, you can see that for security groups, a list of security group IDs. So once again, every security group will have a different ID every time we're gonna create it. So to get this ID, if we move to the security group resource, if we scroll down, at the very bottom, we will have attribute references. In addition to all arguments above, the following attributes are exported. The ARN, this is the Amazon ID, resource number. And here we have an ID. So we can refer to that in Terraform code. Every time this resource will be created, it will be referred in a different one. It means that load balancer will not be created before the security group because it needs to know this ID, right? So the security Terraform will manage that for us. And in this way we can have this ID and you will use the same code and it will work for you. Subnets. So we need a list of subnet IDs. Let's go back. Subnets. A list of subnet IDs to attach to the load balancer. And we cannot be updated for load balancers of type network, but we are using application. Once again, we go to our VPC module, to outputs, and we're gonna see that we will have private subnets, list of IDs of private, also public subnets. And this is already a list, right? So here's a construction to create kind of a list, make a loop. We can change it. We can use module VPC public subnets. Exactly. And we have it. List of IDs. We don't have to put a list around that because this will be already a list. Enable deletion protection. We can have it as false because we're gonna create and delete, but if this would be a production, we can protect from deleting. Access logs. We can have an access logs from our load balancer. For now, we don't need it. We just want to have a simple application load balancer. Also, we can remove tags. Okay. We have load balancer, we have security group, variable, VPC. Our EC2 instance is still commented out. We can comment out cloud front as well, together with S3 bucket. We don't need those at this moment. Okay. I will need to export my AWS profile to be able to interact with Terraform format to have our code better. And let's make Terraform plan. Okay, we see that we have some resources to create, and except of VPC, we will have also a load balancer to be created. Okay, let's try to deploy that. All right. Meanwhile, we can go to our EC2 instance. Let's take a look, and we can uncomment this part of code. It will not affect existing apply. To make quick recover, we have a resource AWS instance. We have an instance type, the image of the instance, the profile used to give some permission, in this case to interact with S3. And we have user data, which is installing Nginx. So by default, we didn't define any VPC configuration here. So let's try to EC2 AWS instance. And let's take a look here. Associate public IP address, whether to associate. So this time we will not want to have a public IP. Let's go. Nation, host ID, instance type, network interface, private IP, secondary private IP, security groups, subnet ID, and we have it here. So we want to have a subnet ID, the VPC subnet ID. So let's take this property here. Copy. And we have an error meanwhile. So we're gonna take a look into that. Subnet ID, we will have our module VPC. And we want to have it in private subnets. So as you remember, for a couple minutes before, this is a list. So if we want to have it randomly to some subnet, we can choose a first position, and this is in programming language. Usually 0 will refer to the first item inside the list. So we could have it number 1 as well, because we define 2 private subnets. Let's leave it here as 0. And let's take a look quickly to security group. Egress rule from port 80 to port 80 must both be 0 to use all protocols. Okay. So we can change this to TCP, and let's try to recreate. -1 means that we will use TCP and UDP. And put a comment on EC2 before that. Okay. Yeah, security group has to be replaced. That's okay. Now it's created, and we're gonna create load balancer, and we have an error. Subnets security group does not belong to VPC 551. Okay, because here we have a VGW and we want VPC ID. That was some problem of auto completion. Okay. Let's try again. Okay, it's creating. I hope this time will be good. We can take a look in load balancers. And we see that our public load balancer is being provisioned right now. There's a lot of things to configure. For now, we just go with some defaults. Let's come back to EC2 and comment. And we can take a look into the instance here, subnet ID. That should be fine. So if we deploy it into the private subnet. It should have only private IP. And we're gonna take a look soon. Let's wait until the load balancer. Then we're gonna create EC2 instance. And afterwards, we will need a target group for load balancer. So the target group will be connected with a listener. So we will define the listener for load balancer on port 80 and redirect to our instance target group. Okay. And we can have a meanwhile also a LB listener. Let's open. And we have examples. So we have a load balancer, we have a target group and listener. These three, they have to come together. This one is for port 443 for SSL policy. We will not need that at this point. You can see we have a port 80, but here default action is redirect. We don't want to redirect that. Okay, load balancer is created. Let's say front end. We can call it HTTP. So we need to again refer to the load balancer ARN in this case. Of course, we take it from documentation front, so we can just remove and became blue. Great. Port 80 HTTP. We don't want SSL any certificate. Default action will be a forward, and then we need our target group. So we need to define a target group. Go back to the target group here, and we want to have instance target group. There might be also an IP, and we're gonna utilize IP in future with ECS, but I want to show you here. Target group, instance ID, or we can make instance nginx. Name, can have, in my case, DevOps codes. You can have whatever you need. And yeah, next lesson, we're gonna utilize a little bit naming convention. We're gonna destroy everything and we're gonna implement a new property here. I don't want to mess up with too many things because we have already variables and we have refers between resources in our today lesson. Module VPC, VPC ID. Okay. Instance target group, VPC ID. Here we have also some of properties that we can take a look. Target type. See down, the default is instance, so we don't have to say it explicitly. VPC IP, target failover, stickiness, protocol name, health check, connection termination, and let's see if we have a target group attachment here. And here we're gonna have to attach an instance to target group and define the port. So that will be one more resource here. Attachment, we can have instance nginx as well. Target group, we take it from here, this ARN, and our instance. So we take also our instance, we call it web server. Go back to LB, change test to web server ID, port 80. And target group we have to update as well. Great. Let's do Terraform FMT. Terraform validate. And I think we will have to make init, yes, because we are using template and I was doing some cleanup of my files, so the provider for template, it has not been installed, and template v220 does not have bucket for current because I'm using MacBook M1. All right, separate from, let's say upgrade. Let's see if this will help us. Let's take a look. Option, and I will do a cut here and let you know if I solved it. Okay, looks like I have to take a look deeper about these providers between AMD and ARM. That might be the issue. However, we succeeded. Okay, and now I see the template is signed by HashiCorp. Okay, we have good checksums. Should be okay right now. Yeah, that's our job. We have to dig in internet many times to solve some issues. Okay, let's try to create once again. This time we're gonna create a listener for load balancer, target group, and attach EC2 instance to the target group, and we're gonna see what will happen. Okay, 6 things to add. Web server. Let's create it and let's go to the web console, see what's going on. So we don't have a listener right now. We don't have a target group yet, or maybe we have it already because it's just created. Also, when we go to our load balancer, we see that we have a listener on port 80 and it's forwarding to the target group. And in target group, we don't have registered targets yet because we are waiting for our instance to be created. Instance is pending. Let's give it a second. Okay, it's running. Oh, still pending. Pending and running. We've got a private IP address. We don't have a public one. That's very good. Let's refresh that. It's initializing. So when we go back to load balancer, we will have a public DNS provided by Amazon. Let's try to open this one on port 80 to ensure. Okay, now we are seeing that probably we have a timeout here. And I think I know why. Because we have a security group, a default one, attached from that VPC because we didn't explicitly define it. And you see that the default security group, it's by itself. So we could solve this in two different ways. We could assign the default security group to the load balancer because we can have multiple here. Or we can create another security group for the Nginx. And we can do this, allow HTTP from ALB, allow HTTP from ALB, allow inbound traffic to Nginx from ALB. VPC, it's the same traffic. We don't want to have encrypted traffic, HTTPS, inside our private VPC. We're gonna have a port 80 to port 80, and we can define the CIDR here for inbound. However, for egress, we want to have all of them on -1 to the internet. It means that our instance will be using NAT gateway to communicate to internet to download, for example, right? We have to update our repo on the OS level. We want to install Nginx. So we have to download it from the internet. And this is thanks to having a NAT gateway enabled. We remember NAT gateway is deployed in public subnets, but it's attached to private subnets. So the resources will have a one-way communication with the internet. All right. So yeah, we have a timeout. We will have a new security group here, and we have to refer to it for our EC2 instance. Let's go quickly to the documentation. VPC security group IDs. And we have it. So we have to add this field for our instance. I'm gonna have dot and dot ID. All right. Terraform format, Terraform apply. This is how we are building the code many times. I want to show you step by step, right? Because I don't want to make it dry lesson. We try to deploy, we see some errors that you might see, and we continuously upgrade our code. And for the security group, the default one will be removed from the EC2 instance, and we're gonna create a new one with ingress from the VPC and egress to the whole internet. That should be quick apply. Modifications complete. And we're gonna refresh, and voila, we have our Nginx served via load balancer. Once again, if we maybe find some application load balancer diagram quickly on internet. So this is how it will work. This one is a little bit more complicated. I can see application load balancer on public internet, and then redirecting over the resources which are in private subnets. This is how it works. That's a very secure solution. Our instance has no public IP. Nobody can connect to it. Nobody can control it, right? We can control it from AWS. There are tools for that. And we can only see the load balancer, which we don't have access to it. We can configure that load balancer, but there's no operating system level that we can connect to. All right, that's all. Don't forget to like the video, leave some comments, subscribe our channel, join our Facebook group, DevOps Codes Academy. We're gonna destroy that stack, and we're gonna see in another lesson. Not sure what we're gonna do there. Maybe configure HTTPS together with the domain. I will show you based on my domain, but of course you can also buy a domain with AWS or any other providers, or if you don't want to, you can only watch the video and see how we're gonna work. Okay, we're gonna destroy the stuff, uncomment here, uncomment here, and we should be good to commit our changes. I hope you're more familiar with Terraform right now and with Git, of course, to make a commit. EC2, we can save it here. This one is newer. What do we have here? Let's just copy this in case. Don't save EC2. All right. Once again, EC2. Yeah, because we need to do Terraform FMT. Once again, all right. Let's do a commit. Oopsie, all changes. Add ALB. Git push setup upstream, right? Oh, we are in master. Okay, we forgot to create a branch here. Doesn't matter. We can make it on master on our own repo. Okay, voila. Thank you guys. See you in the next lesson.